mind that the test is activating at today at I believe 11:50, because that's the official class time is over for this class. I did send out the email with the review. Can anyone confirm if they received it? Now, if you haven't checked, obviously you can't tell me you have it. But for those of you who have checked your email regularly, we are able to access the review in the email?
Yes.
Excellent. And was like the questions like was it decent size? Like were you able to like answer them, like comprehend what it was asking? All right. Hopefully you guys were able to work on it, get some stuff done. I'm almost done with the answer key. More than halfway done. I'll probably finish it once I'm done with the lecture here and do the answer key and then upload it online. Okay, guys? So keep in mind you will be getting the answers for the review today. That way you guys can check your work and grade yourself, and how you did on the review on your own based off of my answers, guys, will determine kind of like how you're going to be doing on my test this week. Now remember, the test is going to activate as soon as class is over, and you can do it from today all the way till Sunday, guys. But the moment you start it, a 2-hour timer does start. So do not, I would be wise with your time. So I wouldn't start it if you have like friends over, family over, and they're gonna distract you, unless you know they're gonna give you your space throughout the test. Perfect. If not, please be conscientious of that. I probably won't do attendance towards the end of class. That way for more students to log on. I know morning classes are kind of a pain. So, all right. Before we begin, are there any questions on the homeworks from 1.7 to 3.2? Any questions on any notes or anything before we start the new stuff? All right, let's get started, guys. So we have 3.3, solving linear equations in one variable. So definition. So what is a linear equation? It's an equation with the highest exponent is 1, but is also called a first degree equation. Example 1, solve the equation, check your solution. 3a minus 6 equals a plus 4. I'm gonna go ahead and give you guys about 2 minutes to set this up into your notebook. More if you need more time. Let's go ahead and get it, guys.
Good morning.
Good morning. Good morning.
Is this the first slide?
Yes, that is correct.
Thank you.
All right, guys. So that was the 2-minute timer for this slide. So let's go ahead and take a look at this equation. So remember, when we solve an equation, your pretty much endpoint is you want to get A equals something, right? We know that that's what we want. That's what we want, A equals. Notice how I like having the variable on the left side, the numbers on the right side. So we're gonna have to do multiple steps to manipulate this equation to get A's on one side, all the numbers on the other side. Now, as we manipulate this equation, it's very, very important that we understand what we're doing. And remember that the example with the weight in the equation is a scale and that both sides are equal. And to keep it equal, what you do to one side, we have to do to the other. That's very imperative, guys, because the moment you neglect that concept, like you don't do it to the other side, you're changing the equation up. Okay, so let's look at the first step. So, and the cool thing about this process, guys, is there's actually multiple first steps. You can move the A, you can move the 6, you can do whatever. As long as you're doing things, you can do it. All right. So remember, so since I want A's on the left side, guys, I'm gonna move this positive A over. And since it's being added to the 4, I can't combine these because they are not like terms. So I could move the A by doing the opposite of what it is. It's a positive A, so I'm gonna do a minus A. And what I do to one side, I'm going to do to the other. So I'm going to drop it here underneath the 3A. So then I'm going to draw the line here. These A's become 0. And then I'm going to go ahead and bring down this 4. And then 3A take away A, there's only 2 A's left, minus 6. And now only the A's are on the left side, right? So now we got to move the constant term, the numbers by themselves to the other side. So how do I move now? Let's see if anyone can tell me. How do I move a minus 6 over to the other side, ladies and gentlemen? How do I manipulate this equation to get this minus 6 over here?
Add it.
Add it. So we're gonna add 6. What we do to one side, we do to the other. Now, this is how you know you did the correct step. You owe me $6, but you give me 6, so now you don't owe me anything. So if this becomes 0, the plus 6 was correct. So let's say it was a minus 6 and you do another minus 6. Well, that's negative 12. So that does not zero out. So that's the incorrect step. You see what I mean? So you should use your logic as you move around like that and then bring down the 2A. So 2A equals 10. And I remember when number and letter are next to each other being multiplied. So we're going to divide by 2. So this becomes a 1. We get A. 10 divided by 2 is 5. And we're done. Now that we're done, we're going to go ahead and check this bad boy out because like I was telling you earlier, I'm independent. I don't need anyone to help me tell me if it's right. I can check myself. So 5 plus 4 is 9. 3 times 5 is 15 minus 6, which is also 9. 9 does equal 9. It's true. So this is the correct solution. And we're done. What questions do we have on the steps that I took to get this solution, guys? Any questions at all? All right. Is there any student that would like more time to copy this work down before I move on to the next slide? Because now you're going to practice an example for yourself. Any question? All right. Let's see how you guys do. Here is your equation. I'm going to go ahead and give you guys 2 minutes to set this up and work it out. If y'all need more time than 2 minutes, I will add more time to the timer. Good luck. All right, guys. Anyone want to talk about what they got for the solution?
-4.
So we have x equals -4. Does anyone agree or disagree with this solution?
How is it -4 again?
Did you say -4? Did someone else say -4?
Oh, that was somebody else. This is
Ah,
Sarah. How did
okay.
you get -4?
Oh, okay. So let's go ahead and talk it out. So if we're missing the equation, so we got to put the line down the equal sign because we want to remind ourselves what we do to one side, we have to do to the other. So someone give me this is a practice problem. So I want you guys to tell me how you did it. So what would you do first, guys? Remember, we want X's on one side, numbers on the other. So can someone explain one of their first steps that they took?
The negative, I minus the 3 on the other, on the left, right side, and then did it on the other side.
Good. And where did you put it under, the 7 or the 12?
The 7.
Good. Okay, when you do that, this becomes 0. I'll say that part, right? What happens to the 7x minus 3x? What's 7 apples take away 3 apples? 4 apples. Bring down the 12. Good job. That was a accurate first step. Now remember, they could have done multiple first steps, but that one does work out. Can someone explain another process now? The next step you would do if your equation looks like this, 4x plus 12 equals -4. What's another step we can take, guys, to get the x by itself? Anyone?
Take away 4?
Take away 4, like from the x, or
Yes.
now we can't really. Now I would say that's true. Take away the 4, but we can't because there's an extra 12 there. We cannot touch this yet until we get rid of every addition subtraction first. So what's the opposite of plus? You have to subtract. What we did to one side, we did to the other. This becomes 0. Now 4x is alone. Now we can mess with this 4. What's -4 take away 12? You owe the bank 4, but you had to spend 12 more. Now you owe the bank how much?
-16.
Good. Now remember what I said about the number and letter. What operation is happening here that we do not see, but we should know every time we see this?
It's multiplying?
Yep. So what's the opposite of multiplying? Let's
Divide.
divide. What we do to one side, we do to the other, and we get x is equal to -4, and we're done. Now you can remember, you want to check, guys. I'm not going to check this one because it's a practice problem, but I'll tell you it is correct. But remember, keep in mind on these practice problems, I want you to check as well because you want to build that technique. Would anyone like me to show you how to check it here, or does everyone understand the concept so far?
I don't understand fully. Can you check it?
Yeah, I can check it. So check. You plug in the solution to x, it'll be 7. Oh. So it'll be 7 parentheses -4 plus 12 equals question mark 3 parentheses -4 minus 6. Multiply these, -28 plus 12 equals -12 minus 6. Subtract these two. -28 plus 12 is -16. -16. That's true. So this is a solution. Any questions on the solving or the checking? So in this section, we're pretty much being exposed to different ways of equations can look like. Here we have the x's on both sides. So now we have to do more manipulation. So here it's the same concept, but there's more steps. We have to simplify and then manipulate. So I'm going to give you 2 minutes to set this up before I start working it out, guys. 2 minutes. Good luck. And then we'll work it out.
Do we combine like terms?
Yes, you will combine like terms per each side. So your first step would be to simplify each expression on each side first. So my timer just is about to go out in 3 seconds. So first thing you do is you draw down the line down the equal sign. And then you look at the left side. What like terms can we combine here, guys?
17 plus 3.
Which is what?
20.
So we get negative 7x plus 20 equals. What can I combine on the right side? Negative,
Negative 3x. Negative 3x.
which gives you what?
0.
Are you sure?
Oh.
So think about it in money. Do you have 3 or owe 3? Owe 3, but you spend 3 more. So in total, you owe how much?
Negative 6x.
There you go. So now now that we have it combined, now we can manipulate it by moving things to the other side. So let's do it. So how would you move it? Now there's more than one first step. And I could tell you what I would do, but I want to know what your first step would be. I want to help solidify what you don't know. So what can we move over, guys? Or anyone? Remember, X is on one side, numbers to the other. So how would you move this around? All right, this is an example, so I'm gonna go ahead and tell you. Now, like I said, there's more than one way. Remember, I tried normally move the X first and then that, but we can actually move the number first. And like I said, there's more than one way. You just gotta make sure you're comfortable with the step and that you're writing everything out. You're not ignoring the sign or anything. This becomes 0. Bring down the negative 7x equals negative 6x. You have $21, but you spend 20, so you only have $1 left. Now we gotta move this x over. The opposite of negative 6x is a plus 6x. Move it over here. This becomes 0. You owe me 7, so you're still gonna owe me 1 at the end of that. Bring down the 1. Divide by negative 1. Remember what I said? A negative 1 just pretty much changes the sign. So this positive 1 becomes a negative 1. And we're done. Now we're done for solving, right? We still gotta check. So it'll be 17 minus 7 times negative 1 plus 3 is equal to negative 3 times negative 1 plus 21 minus 3 times negative 1. Well, these two negatives, so negative 7 times negative 1 is a positive 7. So we get 17 plus 7 plus 3 is equal to negative 3 times negative 1 is a positive 3 plus 21. And then plus another 3 because of this negative 3 times negative 1. Now we add 7 plus 7 is 24 plus 3 is 27 equals 3 plus 21 is 24 plus 3 is 27. And that's true. So this is a solution. Any questions or what questions do we have on the solving or checking over here in this equation? Any questions? All right, let's see how you guys do. I'm gonna go ahead and give you guys 3 minutes on your own example here, okay? Starting now. Good luck. Feel free to type in the chat or unmute yourself and tell the class what you think the first step is. And if you agree with the person, what they say agree or disagree. Don't leave them hanging. That way you guys can kind of work on your thinking on how to solve this. Okay, guys? Um, just because this is a little more complicated than the other lessons, and I do want you to try to pick it up from practicing. So I just set this up. I mean, you should say, hey, I think we should do this on the left side, and it's this. Anyone agree, disagree? And then let's see what the class says, and that way it can help you out with your thinking. Okay, guys. Um, it'll be easier to unmute yourself rather than typing in the chat, but you could do either or and utilize each other. If we were in the classroom, I would have you guys work together in the classroom on these practice problems to help each other out, to make sure you understand, hey, this is right. No, this isn't right. So we're online, so this is the best way we can do it. So utilize each other. All right, guys, that was 3 minutes. Anyone want to share their process on how they did it? Anyone want to share their answer first? Let's see what they got. Do y'all need more time to solve it, or is everyone okay? So remember, to avoid confusion, remember all the steps that I'm doing in these examples, guys. I'm doing them because they're techniques. So the first thing I do when there's an equation involved, I always draw the line down the equal sign to kind of remind me of the two different sides so I don't accidentally combine like the 5 and the 10, because we can't, because they're on different sides of the equation. To combine these numbers, we have to move it over, by doing the opposite. So first things we want to do is we want to combine like terms, right? We want to CLT, combine like terms on each side. So on the left side, what can I combine, guys? Looking at it. This is a practice problem, so I'm not going to do it on my own. You guys have to run me by it.
Would it be 40 plus 5?
Correct, which is?
45.
That's correct. What about the right side?
Negative 2y minus 4y.
And it gives you what?
Negative 6y.
That's correct. Good job. Now we have to get y by itself and the numbers by itself. So how would you manipulate this now? Now remember, there's multiple ways we can go, but what do you think we should do? Now look at the other examples we've done in class. Like those notes are there for a reason. So how would you move this around?
I would add the 10 on the right side
Cool.
and then do it on the other side under the 45.
Let's do it. So this becomes 0. 45 plus 10 is 55. Okay. What's next? Since I will only tell you you're wrong, and I wouldn't do it if it was wrong. Good to have you in class, Carly. All right, what's the next step, guys? Remember, we want to get y by itself, guys. So what's next?
Will we have to add like 5y to 6y?
Yeah.
6y?
Yeah, add the 5y, right? Because we already have the 55 there, so we want to move the 5y. That's correct. This becomes 0, right? Bring the 55 down. You owe me 6 y's, but you're like, I only have 5 on me, sir. So how much do you owe me, or do you have after you give me the 5 and you owe me 6? How does this simplify to? You owe me 6, but you can only pay me back 5.
Negative 1.
That's correct. Now, how do we get y by itself? What do we do to the -1 to get it over here?
We have to divide.
That's correct. We divide, so then we get -55 is equal to y. Now remember, equations can be flipped, so another way I can write this is what way, guys? Right, y equals -55. And we're done, guys. And now remember, you have to check by plugging it in, but we're done. Any questions on the steps, guys? And just to let you know, this is the correct answer. You're good. Now, when you have an ugly problem like this, like to check, you can use a calculator like -5 times -55 and so on. You know what I mean? But yeah, what questions do we have on this practice problem, guys? Any questions at all? Notice how we didn't solve it like the other way. This time we moved the letter to the right side and numbers to the left side, and we still got the correct answer, guys. Like, that's the cool thing about this process is that we can actually manipulate the equation as we please and to get the answer. All right, let's move on. Example 3, guys. Give you 2 minutes to set up. All right, guys, let's go ahead and get started. So first things first, let's go ahead and draw the line down the equal sign. And we simplify both sides. Notice how 9x minus 6 is already kind of good, so we can leave that alone. We're going to bring that just down. But the left side, however, we have the distributive property because we have a 7 with parentheses with x minus 2 inside. So we're going to go ahead and distribute that number so that way we can go ahead and get rid of the parentheses. So 7 times x is just 7x. 7 times -2 is just minus 14. And then boom, we're done with the top part. So now we have to manipulate this, guys, to get x alone. Would any student like to tell me what they would do for their first step? Remember, if it's a step that's not possible, I would tell you and we redirect you.
Will we have to combine terms?
Well, ask yourself, can we combine any terms on either side? Like, can we combine 7x and 14? Can we come? No, right? Why not? What's your reasoning why we cannot do this? Because they are not what? What do we call that term? They're not
Like terms.
Like terms.
There you go. You with me?
Yes.
Good, good, good. So we cannot combine that. It's a great question to think about. So not like terms, so we're done here. But now we can manipulate the equation, class. Now we can do the opposite to move this over here, move this over there, and get this and this, So now that we know that's the process we're at, that's where our head should be at. You tell me what's one step you would do to move something over. Now, when I say over, I mean from one side to the other side, from one side to the other side. So what's one step you would do to get X alone, guys? Because the end game, we want X equals something. That's end game. That's what we want. That's our goal. The X could be on the left side. The X could be on the right side. I do not care because we know A equals B is the same thing as B equals A. So it doesn't matter where the X is at. So you guys tell me what would you move over and how?
Could you do +6 on the right side?
Yes, we can. That is actually one of the first ways we can do it.
What about on the other side if you wanted to do +14?
You could do that as well, but you can only do one. You can't do +6 and then +14. Has to be the same. It has to be one of those steps. But they both will lead to the same correction. If you move the 6 over here, that means you want the numbers on this side, so you'll get a number equals X if we do the 6 first. Now, if we move the 14 over, then you're gonna get the X on the left side. You see what I mean? So it's really up to you. There's no preference. You want to just tell me which one you want to commit with, and then I'll do it on the notes.
Yes, we'll do the 6.
Let's do the 6, okay? So +6, when we do the one side, do to the other. Now, it's very important where we put it at, though. Should we put this 6 under the 7x or under the 14 class? What do you think? Remember, like terms. This is the key to this. Where do we move the +6 under?
The 14?
The 14, right? Because they're both constant terms. This becomes 0. Bring down the 9x, bring down the 7x, and now combine like terms. You owe me $14, but all you had was 6. So after you give me the 6, you still owe me how much? I think it's 8. If I'm wrong, y'all can correct me.
It's not -8, right?
Yes, it is -8. That is correct.
Okay.
That's what it's a minus sign. All right. Now that the numbers on the left side, that means we have to move the X term to the right. How do I move a positive 7x to the other side? By subtracting it. And what we do to one side, we do to the other. Now, the reason why I'm saying we subtract it is because remember, when we move things over, we want to get a 0 like we got here. 7x minus that, it's a 0. So we did move this correctly. Bring down the -8 equals 9 take away 7 is just 2x. Now, x is not alone yet, so can someone tell me how we move the 2?
-2.
Divide.
Why divide? Tell me your reasoning.
Because you're multiplying.
Because we're multiplying these two and it's the opposite. That is correct. Does everyone remember that? If you don't remember that, write this down. Write a note. No. 2x is the same thing as 2 times x. A number next to a variable is always multiplying. Is always multiplying. Just because you do not want to subtract 2 when it's supposed to be dividing 2, because subtracting 2 is always like you want to do the opposite operation, and the opposite multiply is division. So that gives us a 1, x equals -4, and we're done. Now, since this is an example, guys, I am going to check it to show you. On practice, is your job to check, which I don't mind doing if you ask me to. So it'll be 7 parentheses -4 minus 2 equals 9 parentheses -4 minus 6 question mark. -4 minus 2 is -6, -42. 9 times -4 is -36 minus 6, which is also -42. That's true. So this is the solution, guys, and we're done. Now, the reason why I'm going quicker on the checking is because we already covered how to simplify expressions, guys. We know I follow, and the way I did it up there is I follow PEMDAS. I did parentheses first, -6, then I multiplied, then I'm done with the left side. On this right side, I multiplied first, brought down the 36, then I subtracted and got 42. So it's very important that you're also using PEMDAS as you're checking your solutions as well. What questions do we have on this example before I have you practice? Any questions at all? Or comments? All right, here is your practice problem. I'm gonna go ahead and give you guys another 3 minutes, okay? Good luck.
Is the answer 17?
I got 17 as well. A negative 17.
I got positive 17 though.
Never mind, I see my mistake. It's a positive 17.
What's the stop sign?
All right, guys. So we have sorry, I was not on the headset, so I didn't hear. I heard 17 and then I got off the headset real quick. So we have a positive 17 or a negative 17. Let's see what people got. So anyone need me to work it out or y'all want to tell me y'all want me to tell you the answer? So I would distribute that first, right? And then you get 6a minus 30, bring down the 4a plus 4. Y'all want to get a's on one side, so I'm going to subtract the 4a because I like having the a variable on the left side. So this is 2a minus 30 equals 4. Move 30 by adding it because it's the opposite. 2a equals 34. Can someone tell me the final step on getting rid of the 2?
Dividing.
Dividing, and then half of 34 is 17. And then, so that is correct, guys. And remember, I'm not gonna check because it is a practice problem unless someone asks me to. But any questions so far? So everyone okay with the positive 17? All right, let's move on. So you're probably wondering, well, these are the steps that I got from the book. I went ahead and wrote them down. I got it from the book and put it on here, honestly, because it kind of explains on those steps to do this. So I'm gonna go ahead and give you 4 minutes to write these steps down in your notebook because these are going to be very key for you. Because if you're not understanding the procedure, like that process doesn't make sense, or I don't know what to do first. Do I touch that first? Do I do that first? Go ahead and write these steps down in your notebook so you can reference these steps as you're solving equations. Be like, okay, step 1. Okay, there's no distribution. I'm done there. Step 2, combine like terms. Okay, I can't combine that because they're not like terms. This I can combine. I'm good. Step 2 is done. Then it tells you use the addition property to rewrite it. So we have the variable terms on one side and the constant terms on the other side. And then, which is what we do. And after that, we do the multiplication property to divide or multiply, depending on what it is, to get the letter by itself. And then we check the solution in the original equation. So good luck on running these out. Anyone need more time, guys, to copy this slide down? Anyone?
Yes, I do.
All right, I'm gonna go ahead and add 2 more minutes. All right, guys. Anyone need more time than the 2 minutes, guys? More time. All right. I'm taking it. I'm good to go. All right, guys. So, and then I am gonna upload these slides, guys. Not worked out on class. In case anyone needs me to. Oh, I will just do it. The blank slides. All right, let's keep going. Example 4. Solve the equation. Check your solution. So I'm gonna go ahead and give you guys about 2 minutes to set it up, and then I'll get started.
X equals 2.
All right. What was the? Oh, you solved it your own already. Okay. What did you say it was? X equals 2, I think, right? What is it? What you said? All right, let's see. Let's find out. 'Cause I haven't worked it out myself. I just got the sample out. So first things first, we distribute. 3 times 2x, y'all, is 6x. 3 times -6 is -18. We don't include the 6 with this 3 because it's not in the parentheses, so bring it down. Combine like terms, which is the -18 and the 6. You owe me 18 bucks, but all you can give me is 6, so you still owe me 12. You want to get numbers on one side, so I'm gonna move this 12 over. So then this becomes 0. Then we get 6x equals 12 divided by 6. So then we get x equals 2. That is correct. Now we're gonna go ahead and test this out. Two times 2 is 4 minus 6. We get -2, which is -6, which is 0. It's true. So this is correct.
Sir, I got lost after you did the 6x. I mean, after you took out the 6.
After I took out the 6, what part? Oh, like after I combined the terms? Like
Yes.
right here? So you know that I got, you understand why it's -12, right? Like why we got it. You know that part, right? You're good?
Yeah, because -18
Plus
6.
6 is -12. That's correct. So now you're stuck here, right? 6x minus 12 equals 0. Right. So remember, this process is, look at the step. So we distribute it. Yes. Did we combine terms on each side? Yes, because the other side has 0. Now we're going to use the addition property to rewrite the equation. So we have variable terms on one side and the constant terms are on the other side. So we have the variable term is 6x, and then we have -12 all on one side, and then we have 0 on this other side. Well, 0 is a constant. 0 is a number. It just doesn't have any value to it. It's a constant. So if the constant's already here, I'm gonna move this constant over here. And how do I move move a -12 in algebra? We do the opposite, right? The opposite of -12 is +12. And what we do to one side, we have to do to the other. So when you owe me 12 and pay me 12, you don't owe me anymore. So that's 0. So that's how the 6x comes down. 0 plus 12 is just 12. And then we divide. Do you see those steps, Sarah?
Not really, sorry.
So what's confusing you, ma'am?
Okay, so you did the -12 plus 12, and that's a 0.
Mm-hmm.
And then on the other side, 6, take away 6, so it's just x. So then it's x equals, how did you get 2?
Well, how'd you get 6? How'd you get rid of, did you subtract the 6?
I mean, x and then equals nothing, right? That's what I got.
How so though? Because we have to move the 12, remember? And what we do to one side, we do to the other. Did you move the 12 over here as well?
No.
Yeah, that's your problem here. Because remember, we have to do the same thing to keep it balanced. If we're gonna add 12 pounds on one side of the weight, of the scale, we have to add 12 pounds to the other scale to keep it what? To keep
Equal.
it equal.
So then x equals 12 divided by 2.
No. X does not equal 12. What's next to the X still? We haven't touched this 6 yet. You agree with that? We haven't messed with this 6 yet.
Mhm.
So that's why we have 6x here, because we haven't messed with it at all. And then we add 0 and 12, which 0 plus 12 is just what?
So, okay, so then it'll be 6x. So then 6 times x, but you divide.
Yep, we divide because it's the opposite of what? Is the opposite of what?
Multiply.
There you go, ma'am. And what we do to one side, we do to the other. That's how we divide by 6. All
Well,
right.
divided by 2. Okay,
All
got
right.
it.
So let's see how you do with the practice. Okay, ma'am? Ready? Were you good, Sarah? On like the steps? Like, on what, do you have everything written down before I move on?
Yes, sir. Thank you.
Okay, all right. Here is this practice. Try it out. Okay, try it out. I will give y'all 3 minutes on this one.
X equals 0.
All right, we have a potential solution, guys. If anyone wants to agree, disagree.
I got 0 as well.
Excellent, excellent. We have another confirmation.
I think I'm almost getting it, but I'm not sure because I got like 1x equals 0 or something. It's the same thing, right? X equals 0, I guess, now that I say it.
Yep, 1x is the same thing. That is correct. They're both equal. All right. Well, let's see how you guys did. So anyone need me to work this out? Or I will let you know this is correct. Now, but anyone would like me to work it out, or is everyone okay with the steps on their own?
Can you work it out, please?
Sure thing. All right. First things first, we distribute the 4 guys to get rid of the parentheses. 4 times x is 4x. 4 times positive 3 is positive 12. Bring down the +1 equals 13. Then we simplify both sides, combine the 12 and 1 here. So we get 4x plus 13 equals 13. Now we get x by itself. So now we got to move the 13 over because I like the x on the left side. So opposite of positive 13 is negative. What we do to one side, we do to the other. This is 0. Bring down the 4x equals 13 minus 13 is 0. Now 4 and x are being multiplied, so we will divide by 4. You have no pizza at the house with 4 friends over. No one gets pizza, so x equals 0. And you can plug it in here to check. 0 plus 3 is 3 times 4 is 12 plus 1 is 13. So this is the solution. Any questions on the steps we took, guys? Any questions at all? All right, let's keep going. This is the final example of this lesson. So before we go, now we're gonna learn how to write numerical sentences as equations, y'all. We did algebraic expressions, but now we're creating. So I'm going to give you about 6 minutes to create this little chart into your notebook that has the keywords, phrases, and examples of how it will look like written and how it will look like in symbols. And then you'll write example 5 down. Okay, guys? So I'm gonna go ahead and give y'all 6 minutes on this slide. Does anyone need more time on this slide, guys, before I get started? Anyone? Am I able to, can you hear me?
Yes.
Okay, all right. Are we good to start then?
Yes.
Okay, let's go. All right, guys. So that chart is going to be your reference whenever, because you are going to have a couple of these problems on the test as well. So just keep that in mind on how to write an equation, not an expression now, an equation. So let's see how it goes. So we look at example 5A. The product of 7 and 6 is 42. So remember, is another way to say is equal to. Is 5 equals 5. So we know the right side of the equation, the equals, the right side is going to be a what?
Equals
Well, to the right side of the equals. What's going to be to the right side?
42.
There you go. And we want the product of 7 and 6, which we know product just means multiplication. And we're done. You do the dot, the parentheses, whatever. B. So then we have twice the sum of 3 and 5 is equal to 16. So we have the equals to. What should be to the right side of this equal sign, y'all?
16.
That's correct. Now it's twice the sum of 3 and 5. So we want the sum of 3 and 5, but we want twice of that. So what number do I put in front of that sum? I'm gonna put 2. Because remember, twice, we want twice the sum, not twice of 3 plus 5. It's this, we want to double this sum because 3 plus 5 is 8 times 2 is 16. C, the quotient of negative 45 and 5 yields negative 9. Yields is like an equal sign. So then we get equals to negative 9. And we want the quotient of negative 45 and 5. Remember, it's a fraction. So this is first, this is second. So it'll be negative 45 over 5. And those are the equations that we made from example 5. What questions do we have, guys, before I move on to the next practice set for you guys? Any questions on how I set this up? All right, let's see how you guys do. Here's your set of practice problems. Good luck. I'm gonna go ahead and give you guys 4 minutes. All right, anyone want to take a hit on A? Anyone want to try A? The difference of 110 and 80 is 30.
110 minus 80 equals 30.
Good job. Anyone want to try B?
Three in parentheses. 9 minus 11 equals 6.
You sure is 9 minus 11? Because it's asking for the sum of -9 and 11.
-9 plus 11.
-9 plus 11 equals to 6. Now, if we wanted to do subtraction, this here is the same thing as 3, 11 plus -9 equals 6. And we know plus a negative can exist next to each other. It's pretty much a minus. So this is the same thing. So these three all mean the same thing. But look at how they use the order they give it to you, all right? So this is how you would read it from here. But you can manipulate it knowing the properties of mathematics. All right, guys, what's C, the last one?
24 divided by -6
Equals,
-4.
that's correct. Excellent, guys. Any questions so far on how to write equations from sentences, guys? Any questions at all? All right, we're on the right track. Oh, go ahead.
On the second one, so is it okay to put 3 in parentheses and then 9 plus 11 equals 6?
Well, you can't just put 9 though. It has to be -9 because 9 plus 11 is 20 and 20 times 3 is 60. So it has to be -9 because -9 plus 11 is 2 and 2 times 3 is 6. It has to be true, okay?
Gotcha.
All right. Now we're on the last one. So you don't have to write this first part. You already have it written. But I do want you to write the title though. The title of the next lesson and example 1, okay? And it's still equations now, but now there's X involved. X is involved. So I'm going to go ahead and give you guys about 6 minutes on this slide on the title and the examples, and then I'll get started. All right, example 1. So write each sentence as an equation, use X to represent a number, and A says 20 increased by a number is 5. So let me get my pen out. So A. So 20 increased by a number is 5. So 20 increased by a number is 5. And we're done. B. Twice a number equals -12. So twice a number equals -10. C. A number minus 11 amounts to 168. D. 3 times the sum of a number and 5 is -30. 3 times the sum. So with parentheses, this is going to be a sum, a number, and 5. E. The quotient of, so its quotient would be a fraction, twice a number. So this is on top. So the first thing is always on top. So twice a number and 8 is equal to 2. And we're done. Do we have any questions on any of these equations that we created from these sentences? Any questions at all? Because you will have to try to do these on your own in the next slide, in the practice slide. All right, let's get into it. All right, here's your first practice set problems, guys. I'm going to give you about 6 minutes on these, just because there's a lot of writing. I want you to write the sentences and the equation. That way you have the notes to reference as you do the review and the test this week. So I'll give you 5 minutes. All right. Good luck. All right, guys, let's see how you guys did. So anyone want to share what they got for A? Four times the number is 20.
4 times x equals 20.
That's correct. What about for B? The sum of a number and -5 yields 32. Anyone can share.
Is it x plus? No.
The sum of a number and -5 yields 32.
X plus -5 equals -32.
Say that one more time.
X plus plus -5 equals -32.
Well, 32 is just positive in the problem. You see it yields 32, so it should just be a positive 32.
I misread that.
And then you can leave it as is, guys, or remember the ruling. If we have these two symbols, that's the same thing as what operation? Same thing as -5. All right, good. All right, C. Anyone want to try out C? 15 subtracted from a number amounts to -23. Anyone want to try out C?
X minus 15 equals -23.
That is correct. Good job. D.
On that one, could you put 15 minus x equals 23?
15 minus x, they're not the same thing. That is not correct. Because if it said 15 subtracted a number, then yours will be correct. So 15 subtracted number, a number amounts to this. That's when it's 15 minus x equals -23. But it's subtracted from, that's where the order changes. Remember, we wrote that helpful hint in the other one of the other lessons. So, all right. D, 5 times the difference of a number and 7 is equal to -8. Anyone want to take a guess on that? Remember, these are practice problems, so these need to be expressed by you guys, unless someone asks me to work it out. Anyone, 5 times the difference of a number and 7 is equal to -8.
Would it be 5 minus 7x is equal to -8?
5 minus 7x, is that what you're saying? 5 minus 7x equals,
Is equal to -8.
that is not correct.
What about 5 parentheses x minus 7 equals -8?
That is correct. So look how it says here. So it says 5 and then 5 times. So the times knows when it says times, we're gonna go ahead and put the times symbol, which is parentheses. And then we want the difference of a number and 7. Number and 7 is equal to, which we know is equal to, same thing as the equal sign. And then we have -8. Do y'all see that, guys? Do y'all see how we break it down? All right, last one. E. Now, you may not be able to see the connection right now, but you want to keep reading and practicing, reading and practicing. E. The quotient of triple a number and 5 gives 1. Any volunteers for this one?
3x divided by 5 equals 1.
3x divided by 5 equals 1. That is correct. Good job. All right, guys. So, and it's gonna take some practice. You don't remember what I said. Lecture is just to also get you exposed to this, give you some insight, and the practice comes from you doing the homeworks on your own until you get comfortable. Okay. All right. Let's go ahead and move on, guys. We're almost done with the last lesson. So before we get into the last part of the lesson, these are some steps that I want you to kind of set up into your notebook. These are problem solving steps, and these are steps that I kind of want you to utilize as we move forward in the lesson. Okay, so I'm gonna go ahead and give you guys about probably 5 minutes to copy this down, and then finish off the rest of the lesson. All right, so these problem solving steps, so I'm gonna read them to you out loud and kind of talk to you through it. So these problem solving steps are kind of like your recipe for when you deal with word problems. So number one, understand the problem. During this step, you want to become comfortable with the problem, and the way that you're doing this, the way you do this is you read it and you reread the problem. Sometimes it's better to construct a drawing. Sometimes it's to propose a solution and check it out, see if it works. Pay careful attention to how you check your proposed solution. This will help when writing an equation to model the problem. We choose a variable to represent the unknown. Use this variable to represent any other unknowns. Step 2, translate the problem into an equation. Step 3, solve the equation. Step 4, interpret the results. You want to check the proposed solution in the stated problem and state your conclusion. Now, and the way we do that is the same concept. We read the equation, we solve it, we check the answer, and then we say, yes, it's a solution. No, it's not. Right? Is there any student that requires any additional time to copy this slide down before I move on to the lesson?
I need a little bit more time.
All right, I'm going to go ahead and add additional 2 minutes. All right, were those 2 minutes enough time to set up this slide, guys? All right, I'm going to move on. All right, example 2. We'll go ahead and give you guys 2 minutes to set up this word problem, and then we'll get started. All right, guys. So, all right. Example 2, finding an unknown number. Twice a number plus 3 is the same as the number minus 6. Find the unknown number. All right. So first we read the problem. Try to understand it. So pretty much it's kind of like it's a math sentence that can be written as an equation. So let's do that, right? Because we practiced this already. So let's do that. So twice a number plus 3. So what does twice a number plus 3 look like in algebra?
Is it 2x plus 3?
That's correct. What math symbol is? It's equals, right? The same as the number minus 6. So how does that look like on the right side?
X minus 6.
And now it wants us to find it, which is the same thing as solving, right? So let's solve. So we move x to one side. So move this x over here. So then 2x minus x is just x plus 3 equals negative 6. Subtract 3 on both sides to get x alone. X equals negative 9. And we're done. Now, if you want to check it, you plug it into the equation that we wrote. You plug it into, you plug it into this x here. And you should get the same thing, but it does work out, guys. I'll let you know. Save the time.
So
And-
on the left side, you took out 2x, and then you took out the x. I'm sorry.
that is, yes, I did. 2x minus x. I took away one of them, right? If there's two of them, we take away one, we still have one left, which is just 1x. But we know 1x is the same thing as x. Then you bring everything else down, the plus 3, the minus 6. And the opposite of plus 3 is minus 3.
Gotcha.
All right. Any questions on the process here, guys? All right, let's finish off the lesson. So here is practice problem for you guys to work out. I'm gonna go ahead and give you guys 3 minutes to work this one out. Good luck.
Mr. Pacheco.
What's up, Sarah?
I got x plus 2 equals 6 plus 3x.
So you got x plus 2 equals what?
6 plus 3x.
Correct. And how'd you solve it?
I haven't solved it. I don't know how.
Remember, what do we want, Sarah? We want to solve an equation. We want what on one side, what on the other. What do we want?
And the x is on one side and the numbers on the other.
Correct. With that in mind, how would you move things around to get what you just said? To get x's on one side and numbers on the other. What would you move around?
I don't know. Take away the x.
The
I don't know.
this x for this x here?
Mm-hmm.
Yeah, you can do that. How do you move a positive x to over here?
Minus.
Yeah, minus it because there's a positive, there's a minus. Because this gives a 0, right? Correct?
Yes.
So then what we do to one side, we do to the other. Now we're gonna put the minus x there, the 6 or the 3x.
The 3x.
Good. You with me so far?
Mm-hmm.
So then this becomes 0. Now what comes on the next line? What do I bring down the left side?
Plus 2. 2.
Good. And then equals. What comes on the right side?
6 plus 2x.
Good. So now we have the 2x here, right? So what do we need to move from the right side to the left side?
The numbers.
The number. So how do we move the 6 first?
Will you do minus 2?
Minus 2? Ooh, you can't do minus 2 yet. You can't touch the 2 because it's what to the x? It's stuck to the x. So you can't do the 2 yet. You can't do minus 2 because that's stuck to the x. So that does not work out. No, ma'am.
On the left side, you can't do anything.
So what else can we move that's not on the right side that shouldn't be there? Because remember, we want variable term here on the right side because you put the 2x over there, and we want all the constant terms on the left side. So what's a constant term that's not on the left side? What is a constant term that is on the right side of the equation that we should be moving?
2.
Well, the 2 is not a constant term. That's part of a variable term. That's a coefficient. The 2 is part of the coefficient, the variable here. So that's part of the variable term. So we cannot move this 2.
So would we subtract 6?
We subtract the 6 because it's just a constant term. There's no x here. So we have to move it to the other side where the constant terms are at.
So it'll be negative 4. Bring down.
Yeah, it would be negative 4 equals 2x because this is 0, right? All right. Now we just have the variable term, but it has a coefficient. It's being multiplied by 2. So how do we move that over?
Divide by 2.
Yep. We'll get x is equal to negative 2. And we're done. All right. Any questions before we move on, guys? Any questions? All right. Example 3, determining distances. The distance by road from Chicago, Illinois to Los Angeles, California. And y'all can cut off, y'all can lower this word. Y'all could do Chicago, comma, IL for Illinois, and then LA, comma, CA for Cali, and 1,091 miles more than the distance from Chicago to Boston, Massachusetts. If the total of these two distances is 3,017 miles, find the distance from Chicago to Boston. So I'm going to give you about 3 minutes to set up the problem on your notebook, and then I'm gonna go ahead and work it out. All right, class. I know this is like a pretty like hefty word problem, so I'm trying to be understanding of the writing. So the distance by road from Chicago, Illinois to LA, California is 1,091 miles more than the distance from Chicago to Boston, Massachusetts. If the total of these two distances is 3,017 miles, find the distance from Chicago to Boston. So find the distance from Chicago to Boston. All right. So we know this. So we know the distance from Chicago to LA plus the distance from Chicago to Boston when we add those both up, we know it adds up to what? 3,017 miles, right? That's the total of these two. So we know, so find the distance. So what is our unknown variable? What don't we know and that we want to find? Anyone want to tell me?
Chicago to Boston.
There you go. So right there, Chicago to Boston, the distance from that, and we're gonna call that X. Find X. So this is gonna be X right here. This distance from Chicago to Boston. Bring down the 3,017 miles. Okay, now, but how can we describe this distance from Chicago to LA in terms of X? So let's read it one more time, the first sentence. The distance by road from Chicago to LA is 1,091 miles more than the distance from Chicago to Boston. Well, more than, what operation is more than?
Plus.
Plus, so we're gonna be adding, right? So it's adding to what? Chicago to Boston, right? What do we call distance from Chicago to Boston? What do we call that? Call that X, right? How many more miles from Chicago to Boston is it? 1,091. You see how we did that? How we created a word problem of a distance that had no letters, no variables, and we made it into an algebra equation. So now we have 1,091 plus x equals 3,017. Now we have an equation. So let's solve it. So do we have any like terms on the left side, guys? Yeah, right. X and x add up to how many x's total? 2. So then bring down 1,091. Now we want to solve for x. So we're going to subtract 1,091 on both sides. So we get 2x is equal to, this is got borrow from this one to make it 10, to make it 9, to make it 11. 7 minus 1 is 6. 11 minus 9 is 2. 9 minus 0 is 9. 1. Now, you can always use a calculator for this step, guys. I just don't have one. Oh, I do, right? But I like to do it by hand. So then divide both sides by 2. So we get x is equal to 19 will be 9, 12 will be 6, 3. That's what I'm thinking. Let me double check. This is 9, 6, 3. Okay, yeah. And we're done. So from the distance from Chicago to Boston is 963 miles. And we're done. And for you guys to get to this part is you want to keep rereading that problem, breaking it down, and trying to make sense of it using your knowledge and all the other resources we've done in class so far. All right, guys. So let's move on. Let's see. This is what we have. Let's try it out. I'm gonna give you a practice 3. I'm gonna go ahead and give you 4 minutes on it. You don't have to write it down. You can just read it and make the problems from what you write down, like your own, or you can take a picture of it on your phone and then write it down later. But I'm gonna give you 4 minutes to try to create a algebra equation and to solve for what it's asking for. Good luck. All right, guys. So anyone want to talk to me through their process on this? Word problem says the distance by road from Cincinnati, Ohio to Denver, Colorado is 71 miles less than the distance from Denver to San Francisco. If the total of these two distances is 2399 miles, find the distance from Denver to San Francisco. Would anyone like to share with the class their process on how they took this word problem and created an equation and solved it? And it's very similar to the last example we did, but just different destinations now. So if anyone wants, anytime.
Would it be 71 minus x in parentheses and then plus x equals 2,399?
So we have 71 minus x plus x equals to 2399. Does anyone get something different? So whatever x is, so I want you to think about this expression right here, Sarah, 71 minus x. So let's say x was 100 miles, right? And it's gonna be more than 100 because we have a big number here, 2000 something. Now, 71 minus 100, that's negative 29. Can we have negative distance in miles?
No.
No, right? So since we can't, 71 minus x isn't the correct way to write it. But remember, it's less than, right? So it's 71 miles less than the distance. So the distance of the Denver is X, right? We know it's X, the distance from Denver to San Francisco, but it's 71 miles less than that distance. So whatever that distance is, it's going to be less than 71. So we're going to have to subtract the 71, not the other way around. You know what I mean? So I know that this is the confusing part. If it was just less by itself, it would be 71 minus x. But when the than is there, that changes the meaning of less. Okay. 71 less the distance is the way you said it, but 71 less than, that changes it a little bit. So not a little bit, but a lot. All right. Now that we did that, we can go ahead and solve for x, right? We can draw the parentheses because there's nothing else there to do. But how would you solve for x, guys? You tell me the process now. We have this equation.
Would you take away x?
Well, no, because remember, the point of solving equations is you want the x on one side and the number on the other side. So if we subtract the x, we're gonna have one x on each side. So subtracting x doesn't really help. But you're not really following the steps, Sarah. Remember, you have the steps on solving equations. So what can we do on the left side?
Combine like terms will be 2x.
Combine the like terms. You have to follow the steps. And then we get 2x minus 71 equals 2399. All right. What's next after that, guys? Now we want to get x alone, right? So what do we have to move over?
Add the 71.
Yep, add the 71. And then final step, how do we get x alone? We divide by 2. So we get x is equal to 1235 miles. So the distance from Denver to San Francisco is 1235 miles. Any questions on the setup or the solving? All right, guys. We're gonna go ahead and not worry about this example. I went over the test and you should be okay. There's not really a problem that talks about software. So we're gonna probably do just 3 examples just because word problems are kind of exhausting. But all right, now let me go ahead and go over test 1. Test 1 will be activated today at 11:50. I emailed you the review based off of the test, guys. So it's very important that you guys cover these sections, have all the lecture notes in your journal. So if you've been coming to class every day from last week to this week, you should have all the notes in your notebook. It is going to be 25 questions and you will have 2 hours to complete. So the moment that you start it, you will have 2 hours to complete it. And you have from today until Halloween Sunday. Now, I'm not now, if other students say that that's not how their teachers do it, don't, because I don't know if you have friends that are taking the same class but different professor. I'm very different, guys. Everyone else is doing it during class. I feel to prepare you for college. College kind of lets you do the test whenever. It's the midterm and the final that we'll be doing during class. All right. But the other tests, I'll let y'all do at home over the weekend. That way you can practice the homework assignments, do the review and be like, okay, I have my notes, I have the homeworks, I have the review done. Now I have all the resources that I felt like that were available to me. And so on. You know what I mean? So what questions do we have so far about my class or anything regarding my class? Are there any questions at all? Does everyone understand what is being asked of them for this week?